Hi, this is Mrs. Tellas. We're going to be starting chapter 3 today, which is we're going to be able to determine whether a relation is a function, find the domain and range, and identify independent and dependent variables. And again, this is section 3.1. So a domain is all the x values, especially if you have a list of them. It's the first number in the ordered pair or pairs. Range are the y values, the second number in an ordered pair. A function is an x coordinate that cannot be repeated in a relation in which each element of the domain is paired exactly with one element of the range. So when you're looking at a relation or a table or a graph, what you're looking for is that all the x's are different. All the x coordinates are different. None of the x's can repeat, and then it's a function. So if we go here, this first one right here is called a mapping. Okay, it's got the two circles and the arrows connect. So we could list the ordered pairs. We'll do it underneath here. You can see what is attached by the arrows. So -2, -8, 0, 0, 2, 16, and 4, 8. So there are the ordered pairs. I can tell that this is a function because every one of these x's is different. Okay, I can tell that the domain are all the x's, so -2, 0, 2, and 4. And I can tell that the range are all the y's, so -8, 0, 16, and 8. Okay, and again, I know it's a function because every single one of these x's are different. Okay, and again, this is called a mapping. The mapping, the numbers don't have to be in a particular order. They just have to have an arrow between the x and the y. There is one thing about the mapping, though. You can't have any repeaters in either of the circles. So if you did a mapping and there was a repeater, you just have two arrows either coming off of it or going to it. So same thing here on the table. There's no arrows, but you can tell what the partners are. So we've got -7, -12, -4, -9, 2, -3, and 5, -3. Okay, so my domain are all the x's. So -7, -4, 2, and 5. My range, -12, -9, -3, and -3. And on that, you wouldn't have to list that -3 twice. You can, but you don't have to. And yes, this is a function because all of the domains are different. It doesn't matter that the ranges repeat. Only the domains make it a function or not. Okay, so a set of ordered pairs is called a relation. Okay, I can tell here that the domain is -5, -2, 0, and 0. I can also tell this is not a function. And it's not a function because it's got repeater zeros in the domain. The range is 2, 5, 7, and 9. Okay, let's go to the next page. So you did the vertical line test in pre-algebra. Let's see if you remember. It says if no vertical line can be drawn so that it intersects the graph more than once, then it's a function. So if I look at this parabola right here and I draw a vertical line anywhere on it, a vertical line would be nice. There we go. So straight up and down. If no matter where I draw it, it only hits the graph one time. And what I mean by the graph is I mean the parabola. Then it's a function. So yes, this is a function. Okay, there's nowhere I can draw a straight up and down line and it'll hit it twice. So if we look at this one vertical line hits it 2 times. This is not a function. Okay. The domain and the range for each. Okay, this concept is new. Okay, so let me get rid of those vertical lines. All right, so if the dots stop here and they're not arrows, so the domain is anywhere on the x-axis where you could make a point. So it starts about right here, and this is going to be an estimate because it's not right on that line, but it's about right there is where it starts on the x, and it goes about to right here. Okay, so it's a range of numbers between, let's see what this is, -1, 2, 3, 4, 5, 6, 7, and a little bit more. We'll go -7.25 and 1, 2, 3, 4, 5, 6, so it's about 5.75. Okay, so that's my range. And what I do is I put x in the middle. This is the domain because I'm looking at the x-axis. And it's less than equal to, and then this one over here is exactly the same. They always match. And if I do the range, I do the same thing, except instead of doing sideways, I do it from up and down. So it starts right here, all the way across, and it goes all the way down to about right here. So on this line. So let's see, it goes up 1, 2, 3, 4, 5, 6, 7. So 7's my big number. And -1, -2, -3, 4, 5, 6, 7. So it's a range between here. So again, I put less than equal to and less than equal to. Okay, because it's below 7 and it's above -7. Okay. If I do this one, it's the same thing. Okay, there are no arrows. Let's actually put some arrows on here so we can do one that's all real numbers. So if I'm looking at the domain, it starts here, the x's, and because it's got the arrows, it goes on to positive infinity. So I could write this set as the domain is x is greater than or equal to 1, 2, 3, -3. So it's everything from -3 on to positive infinity. There is a point because of those arrows. Okay, and then if I look at the range, that's where it's between, this should be a y on the range, not the x, my bad. All right, and then that's between the tops and the bottom. But again, it goes up forever and it goes down forever. So it will eventually reach, if it could possibly, positive infinity and negative infinity on the bottom side. So this is all real numbers. Because I can always put a y point because of the arrow. Okay, and I'm looking on the up and down for that. Okay, and then we didn't say whether they were functions. So is this a function? Yes, this is a function because no matter where I draw a line, it only hits it twice. And no, this is not a function because if I draw a vertical line, it hits it 2 times. Not a function. I think I might have done that. All right, let's try this one. Number 6, this is a function. Yes. Okay, the domain and the range. Okay, let's practice this. So the domain is where it is. It's between this line and this line. And see how they're closed dots? Okay, so it's between here and here. Those are the only points. So my small number is 1, and my big number is 1, 2, 3. X goes in the middle. It includes those because it's this closed circle, so I put less than equal to. That's my domain. And my range is the same thing. It's just on the y-axis. So if it's from here up to here. So let's see. My top number is 10, 9, 8, 7. And my bottom number is 3. Y goes in the middle. And again, they're closed, so it's less than equal to, less than equal to. So that's my range. And yes, it's a function. No matter where I draw the straight up and down line, it only hits it once. And this is also a function because no matter where I draw it, it only hits once. So the domain is where this applies to the x. Well, do you see these arrows? It applies everywhere to the x, all the way to positive infinity and negative infinity. So this is all real numbers. And then for the y, or the range, it only applies here on 1, 2, 3. Okay, no matter what the coordinate is, the range will always be 3 because it's linear and it's always going to be sitting on that y equals 3 line. So my range here is y equals 3. We already did that. Okay, is this a function? No, it's not. Because if I draw a straight line down it, it hits it infinitely. It hits it infinitely. Is this a function? Well, when I draw a straight line or a vertical line, it hits it twice. So no, that's not a function either. Okay, the domain and the range. So the domain, it only hits the x right here. There are no other points of hitting the x. So 1, 2, 3, 4, 5. X is -5. And the range is all real numbers because of these arrows. It's going up forever and down forever. So this is all real numbers. A vertical line is the only line that's not a function. All lines are functions except for vertical lines. It's linear, it's just not a function. Okay, over here, the domain and the range. This one's a little trickier. Okay, so let's get rid of this stuff here. All right, so my domain is the x. So I look at the x and it looks like it starts about right here. and it goes all the way to over here, right on that line. So my big number is 1, 2, 3, 4, 5, 6, 7, 8. And my small number is 1, 2, 3, 4, 5, 6, 7, 8, 9, and a little bit more. I'm going to go with 9 and a fourth, and it's negative. X goes in the middle. They're not open circles, so we're going to do less than equal and less than equal. That's my domain. And then my range, I do the exact same thing. I just do it on the Y. So it starts on the Y here, and it goes up to the Y here. So my small number is negative 1, and my big number is 1, 2, 3, 4, 5, 6, 7. 7. And totally includes those. They're not open, so it's less than equal to and less than equal to. Okay, so independent and dependent variables. I know that you do this in science, and I know that you did it in 7th grade science too. So your X is your independent variable, and your dependent variable is your Y. Okay, so domain also goes here, comma, range. Okay, so the dependent variable is your Y. Okay, it is your output value. Okay, and we can also do it input and output. Input and output. Okay, all right, let's go here. All right, so I've got this function right here. Y equals negative 3x plus 2. My highlighter's yellow, that's why it's not working. There we go. It represents the amount of juice Y. So the amount in fluid ounces is Y. That means it's your output. It's your dependent variable. Okay, it's your range remaining in a bottle after you take X gulps. So X is your gulps, and it's also your independent because it's X. It's your domain. It's your input. Okay, so identify the independent and dependent variables. Well, we just did that. Okay, so X are my gulps, and I know that because it tells me in the X gulps. So this is gulps, which is my independent variable. And output is juice, amount of juice in fluid ounces. Amount of juice. Okay, and then it says identify, and that makes it my dependent. I'm going to abbreviate it. Identify the independent and dependent variables. We did that. Find the range of the function given the domain. Okay, so they're telling us that domain is 0, 1, 2, and 3. We have to plug these in here for X and come up with the output or the Y or the range. So negative 3 times 0 plus 12. If you put this in your calculator, you'll get 12. So you're looking for the range, so that's the first answer, 12. Okay, so negative 3 times 1 plus 12, that'd be 9. So my second answer is 9. Negative 3 times 2 plus 12, that was 6. And negative 3 times 3 plus 12, that is 3. So my answer, that is my range or my output or my dependent variables based on the inputs that were put in, or it's also my range. Okay, so I have another one here. Why don't you press pause and give this a try? Okay, so we're going to decide what is the independent and dependent variables. We are going to plug into a table for an oven temperature of 350 degrees. So you really don't need a table. You could just plug 350 degrees into your equation. So go ahead and press pause and try this. Okay, so it says the function t equals 19m plus 65. Well, I know that this is my y and this is my x, right? Y equals mx plus b. So minutes is x. Okay, this is my x, which is also my domain. It's my input. It's my independent. Okay, and that means t is my y or my dependent or my output or my range. Okay. All right, so it says that I'm plugging in 350 degrees. Well, is that minutes or is that temperature? Well, that's temperature. So I'm putting 350 in for T. So 350 equals 19m plus 65. Well, I can just solve that. using my fantastic solving skills we got from chapter 1 and 2. So that's 285 equals 19m. And I'm dividing. I have a calculator here. Let me make sure I subtracted correctly. 350 minus 65. Yep. And then divide 19, not 15. And I get 15. So 15 minutes is my answer. Okay, the domain was 350. Actually, no. The range was 350 and the domain was 15. And I know that because minutes is x. Okay, and since it's x, it's domain, it's input, it's independent. Okay, so your assignments in Big Ideas, go ahead and give that a try. Make sure you submit your work on Canvas and put the answers into Big Ideas.